So the first thing is, what is chemistry? Well, chemistry is the study of matter and the changes it undergoes. We see the changes around us all the time. When milk goes bad, we note the changes. Um, when you make some toast, you see the change in the bread. Now, matter itself is anything that has mass and occupies space. Occupying space means it has volume. Now, how do we study matter? We study matter by observing it. When you observe it, you ask yourself some of these questions. Is it a solid, liquid, or a gas? Does it have a color, a shape, an odor? What does it look like? Anything you recognize? Is it warm or cold? Is it heavy or light? We can put observations into two different categories. One is qualitative, which denotes some quality of the substance like color, shape, or phase. And the other type is quantitative, a measurement or comparison. So when you think of quantitative, you talk about using a balance or a ruler or something like maybe a graduated cylinder, something to measure a property of a substance. Here are some of the units that we use in the metric system. SI stands for the International System, which is pretty similar. You'll see some changes like in volume and mass. In this country, we use a combination of it, so we kind of use a pseudo-metric system. This here is just showing you the difference between yards and meter sticks. A meter is about 3 inches longer than a yard being 36 inches. For volume, we have a liter and a quart being very close. You notice that a quart is actually a little bit less than a liter, 946 milliliters. And here we are weighing a chocolate, and we're weighing it in grams because that's the basic unit of mass. And we're getting 3 digits to the right of the decimal point. So that's a pretty good amount. So we have 23.089 grams. So we measured it all the way to the thousandths place. Now on to temperature scales. We have centigrade and Kelvin here. You might have a thermometer like this outside your home. I have one outside a window so I can see what it is, especially in the winter. So let's see. You can notice that here we have, it looks about 66 or so maybe Fahrenheit, and that's around 19 maybe, 18, 19 degrees centigrade. I'm trying to read that. So you notice we're not too accurate with this. It looks like the Fahrenheit scale has more graduations versus the centigrade, so it might be a little bit more accurate. We have a couple of formulas for calculating temperature changes. One is for Fahrenheit and centigrade, and the other is for Kelvin and centigrade. Now, many of you may not have heard of the Kelvin scale before, but the Kelvin scale is based on the motion of molecules. The faster molecules move, the higher the Kelvin temperature. The slower they move, the lower the Kelvin temperature. When molecules are no longer moving at all, they're at 0 degrees Kelvin, and that's called absolute zero. The other two temperature scales are both based on the boiling point and the freezing point of water. Now here are 3 questions that you can try before going any further to see if you can get them right. So you might want to stop the video and write these down on paper and come up with the answer, and then come back and see the solutions done out. Okay, on to the solutions. Now here's the first one. I'll write down my formula. I make my substitution. For the centigrade, I put in a 30. I do the math, and there is that. So 86 degrees Fahrenheit is my answer. Couldn't be simpler. But I'm going to use the same formula for the next one. Here's my question. Now, here's my formula, same formula. Now this is what I'm doing different. I'm going to make my replacement. So 30 goes in for the Fahrenheit. I'm going to put an X in for the centigrade symbol. Now I want to get X by itself, so I'm going to subtract 32 from both sides. That'll give me minus 2 equals 1.8x. And then I'm going to divide both sides by 1.8. So I'm going to draw my line here. So here's my line like that. Here's my line. Now these would cancel out, and then I would solve it, and I'd get minus 1.11 degrees centigrade is equal to x. Pretty straightforward. Now for my next one, 78 Fahrenheit to Kelvin, I'm going to use both formulas. And so I start with my Fahrenheit, 78 equals 1.8x plus 32. Subtract 32 from both sides would give me 46 equals 1.8x. Now divide by 1.8 on both sides, and I get 25.6 equals the centigrade temp. Now I'm going to go over and put my 25.6 in for my centigrade, my Kelvin formula. And I just have to add them together, and I get 298.6 Kelvin for my answer. So that's pretty straightforward. And I'm going to just get back to my arrow. Okay, here we go. All right. Next topic, scientific notation. It's used to write very large or very small numbers in a nice compact format. And you can see over here on the side, here's an example of it. You might remember how to do this. Here's an example here. I'm going to go through this in the next slide. Can you read how much these numbers are? So the first one, that's going to be 8 millionths of a meter. And I can tell just by looking at the power of 10. And here's the opposite, a very large number, that's 4,500,000. And that's how we'd write that in scientific notation. Now this is the basic format for scientific notation. You have a number that has to be between 1 and 10. It can't be 10, it can be up to 9.99. It has to be 1 or more but less than 10 times 10 to a power. And this power will either be a positive or negative whole number. It could even be 0, but there's no point in writing that. Okay, so here we go again. So let me go through a couple of them with you. So we start off with 4,500,000, and I'm breaking that down into 4.5 times a million. And now I'm going to work on the million. So a million would be 10 times itself 6 times, which I can then write as 4.5 times 10 to the 6th. Now, a simpler way to do this would just be to move the decimal point. So if I go back to my pen again, here's where my decimal point would be. If I were to move that decimal point down and stop it between the 4 and the 5, that would give me a number between 1 and 10. And then if I count the number of places I moved it 6 places. And that's going to give me the power. Now this was a real big number, and I made it smaller by moving the decimal point in this direction. Therefore my power of 10 would be positive. Now let's look at the other number. So now we have 8 millionths, which can be written as 8 times 1 millionth. And I'm going to work on the 1 millionth. So 1 million can be written as 1 over a million, or it can be written as 1 times 10 to the 6th. Now 1 over 10 to the 6th can be written as 10 to the negative 6th. So this negative sign down here, that just means 1 over. The other way to get it would be to move the decimal point all the way down and stop it just past the 8. And then count the number of places I moved it, which was 6 places. But in this case, I moved it 6 places to make the number bigger, and therefore the power of 10 becomes negative. Let me get rid of my pen now. All right. So here are some for you to try. So you might want to pause the video now, copy these down, answer these, then come back up and check your answer. All right, and here are the answers. Here are the first 3. Remember, moving the decimal point in whatever direction to get a number between 1 and 10. In the middle group, you're asked to convert these back to regular numbers. So this would say move it 3 places to make the number bigger, move it 4 places to make the number smaller, move it 7 places to make the number bigger. And here are our answers. And the last one, which is the greatest and which is the least? That's really, we get that by looking at the power of 10. So the question is, which power of 10 is the greatest? And it's this one. And those are our answers.